All right, SOHCAHTOA. Each letter in SOHCAHTOA stands for a different word. The main one would be the S, the C, and the T. Go ahead, shout out. What do those stand for? Oh, that's wonderful. That's wonderful. And what about the O's, the H's, and the A's? Fantastic. And what are those referring to? Opposite, hypotenuse, and adjacent. What are those things? Good. Those are the different sides on a right triangle specifically. What does a right triangle mean? How many 90-degree angles? Could it also have two 90-degree angles, though, and it still be considered a right triangle? Why not? Yeah, you can't have a triangle with two 90-degree angles because, look, like if that's a 90-degree angle and if this is a 90-degree angle, are those sides ever going to meet? No, they're both going to go up forever and never meet. What do you call lines that go on forever and never cross? Oh my gosh. It's like all of last year all over again in the first 5 minutes of class. It's pretty groovy, right? All right, so sine, cosine, and tangent. You're familiar with those. I'm going to go over all of them in more detail and show you how to use them. What about this crazy word, Pythagorean theorem? A squared plus b squared equals c squared. And what's that used for? Only the hypotenuse?
It's used to find the side of a triangle.
Side of a triangle. So it can find any side length of a triangle? Any type of triangle? Or is it only for right triangles? It's actually just for right triangles. And so today we're going to focus on just those methods. Like that's it for today. Isn't that pretty cool? Like you feel kind of good about this, don't you? You know this stuff? I'm not even going to make it crazy difficult by the end like I usually do with my lessons. I promise. I think. No, it's going to be good. It's going to be good. All right, so Pythagorean theorem and basic trig. So first off, this is not a learning target that I'm going to assess you on because this is a learning target from last year, from geometry. And so normally I label my lessons based on your target, 8.1, 8.2, 8.3. However, as this is not one, I've labeled it 9.0 because it's not an actual learning target. However, we do need to make sure we still understand these concepts when moving forward. You need to understand these. You won't be specifically tested on this concept, though, is what I'm saying. So let's start with the Pythagorean theorem. This is one that you've probably heard of even before geometry class last year. And so if you know the lengths of two sides, any two sides in a right triangle, we can use this Pythagorean theorem to calculate its third length. A squared plus b squared equals c squared. A, b, and c just refer to the different lengths of the right triangle. And the only thing that you need to make sure happens is that c, right there, c is the hypotenuse. How do you know which side on a triangle is the hypotenuse? Are they always labeled for you? Like when you have a triangle, is it like, boom, I'm the hypotenuse? Does it tell you? All right, so one thing is that it's the longest side. But what if you have a picture of a triangle and you don't have the lengths given to you? What if they're blank? How can you tell?
It's the one that's not connected to a 90-degree right angle.
Yeah, it's opposite of the right angle, or the one not connected to the right angle. So if I've got a right triangle like this, even though I haven't, I'm pretty good at drawing triangles. You're going to see a lot of those today. If I've got a triangle here, you should be able to tell from the picture which angle is the right angle. And they're going to be given to you with this little square symbol or half box symbol in the corner. That tells you that that's the right angle or the 90-degree angle. There are two sides connected to that right angle. Okay? So there are two sides of a triangle that kind of form that right angle. Those two sides of the triangle are called the legs. And the legs are labeled A and B typically. It doesn't matter which one's A and which one's B. They're both just the legs. Now there's one side that's not a leg, that's not making the right angle. It's actually across from the right angle. And that's this side right here. So this is C. That is the hypotenuse. So it's the longest side and it's across from the right angle, or it's across from the 90-degree angle. So that's how you're always going to know which side is your hypotenuse. Now, an important disclaimer that I need to make that was also made in geometry. The drawings that you're going to see for these different triangles are not drawn to scale, meaning just because an angle looks like it's 90 degrees doesn't mean it actually is, unless you see that symbol, that half box. Because if you had a triangle that instead of 90 degrees, if it were, I don't know, 89.5 degrees, do you think your eyes could detect the difference of half a degree? I know mine can't. I'm not that good. All right. And so it might be only like 1 degree off and you wouldn't be able to tell. It would still look like a right triangle. So you can't assume that it is. And so the drawings are never to scale. Even if things look like, oh, these look like they're the same length. You can't assume that unless you see some type of a marking like this. Do you remember those congruent symbols from geometry last year? If there's like a single tally mark on multiple sides, it means that those two segments are the same length. So here I can assume that this is a right triangle and that it's got two congruent sides, or those two legs are the same length. But I can only say that because I have indicators in my diagram that tell me that that's true. Without them, they might be, they might not be. So I don't know. That might not be a right triangle. Those two sides might not be the same length. Right? Even if you measure them, you're like, no, look, it is. You still don't make assumptions on math tests that have drawings of shapes. Always go by just what they tell you. All right. I want all of you to try using the Pythagorean theorem. I got 3 triangles for you, 3 unknown lengths, x, y, and z. If you'd like, I will set up the first one for you. And I want you to do the others on your own. You should be able to do all these on your own. So I'm going to start with the 2 legs that make up the right angle. I'm just going to call this side A, this side B, and this hypotenuse has to be C. So when I plug those all in to my Pythagorean theorem, a squared plus b squared equals c squared, I'll get 10 squared, because that's A, plus b squared, well, b is x, and that's what I'm going to be solving for, plus x squared equals c squared, and that's 26. And so you're just going to solve that equation for x, which all of you should be able to do. We've done way more difficult equations this year. And I want you to solve each of those unknown side lanes. Just a little refresher from last year. Go ahead and take a few minutes and see what you can figure out. See what you remember from last year. Oh, did you do it all in your head? All 3? So did. All right. How many of you got at least the first one done? Okay. Dun dun dun. Well, you know where I'm going to be. Ooh, what about that one with the square root in it? That's got to be difficult.
I mean, if it was the square root of the square root, which case would just be the square root of 15.
Don't worry, we'll have some. The fun math will come on Thursday.
Is that like triple squared?
No.
You gotta pull one out.
100 plus x squared equals, what is 26 squared? 676? So then x squared equals 576. And hey, when I've got x squared, I need to cancel out the square. What operation do we use? What's the opposite of squaring something? The square root, right? So you square root both sides. And what does x equal? 24. Now, here's the thing, everybody. Earlier in this year, when we worked with radicals, I said, hey, if you ever solve an equation by using a square root, what do you need to put in front of that number? Remember, we're solving this equation for x. So if you go back one step, where it says, hey, x squared equals 576. So 24 is x, because 24 squared is 576. But is there another number that when you square it, you'll also get a positive 576? River, what is it? That's right, negative. So that's why I said whenever you're solving an equation by square rooting, you got to put that plus and minus in front of it, because it could be 24 or negative 24. But wait, as I see all of you grabbing your pencils, Ben, what am I forgetting here? We're solving for the length of a triangle, exactly. Can I have a negative length, like negative 24 inches or whatever? Does that, can we ever have a negative distance? No, we can't. And so because of that, you do not need to put the negative sign. It is only a positive 24, and that's going to be true whenever we're solving for lengths. So if we were just solving the equation, we'd have a plus and minus. But here we have to use just a little bit of common sense to recognize the fact that, oh, x, it's not going to be a negative 24. I can't measure negative 24 feet or whatever. So it's just going to be a positive 24. All right, and the middle one, we plug things in. So look at the right angle. So I know that these are the legs, which means that's the hypotenuse. And the only thing different here is I've got the square root of 15 squared plus 7 squared equals y squared. That first term, square root of 15 squared, what does that actually equal? Yeah, those are like opposite operations. So sometimes students see that square root and they get scared. They're like, oh my gosh, that's going to be really difficult. I don't want to deal with it. But it actually makes it really easy in this case, because the square root and the square are just opposite operations, so they cancel each other out. And this is just a 15. 7 squared is 49 equals y squared. Add those up, 64 equals y squared. So what does y have to equal, everybody? 8. What about negative 8? Why not? Lengths cannot be negative. All right, so y equals 8. The hypotenuse, a squared plus b squared equals c squared. Okay, questions on that middle one? I'm assuming no. And then this last problem, 2 squared plus 4 squared equals z squared. So that's 4 and 16. This isn't going to work out nicely, is it? Not quite. If you type this into the calculator and you get a decimal and you wrote that down, you have the wrong answer, because you did not include every single decimal point from that square root, did you? No, because decimal goes on forever. It's an irrational number. Z equals the square root of 20. What should we do with that number? Simplify it. Do we know how to simplify radicals? Yes, that's a skill we learned earlier this year. So you want to break it down into two different factors that multiply to 20. And one of them you want to be a perfect square. So what are those two magical numbers we want to use? Yeah, if I say this is 4 times 5, or more specifically, the square root of 4 times the square root of 5. Well, I like these two factors because 4 is a perfect square. I can take the square root of 4. We know that it's 2. So that's a 2. I can't break down the square root of 5 any further, though. But this is how we're going to need to write our answers, in simplified radical form. I'm pretty sure you did those last year in geometry too, didn't you? Simplifying radicals? I'm pretty sure. That shouldn't be a brand new skill this year. But something we want to focus on because it is the precise exact value. All right, now for trigonometry. All the words up top is just generic math talk. The important thing are those 3 different boxes at the bottom of the screen. So trigonometry is used to relate side lengths to angle measures. It's a ratio, a fraction. Our 3 basic trig functions are sine, cosine, and tangent. And each of those 3 trig ratios, or 3 trig functions, represents a specific ratio on a right triangle. Now, that x in the middle isn't a side length, that is an angle. You might want to make a note that these are all angles. So you'd write the sine of some angle, 30 degrees, for example. The sine of 30 degrees equals the opposite side of a triangle divided by the hypotenuse of that triangle. And this is specifically for right triangles only. So I want to make sure you just have those 3 ratios written down. You might even remember them from last year, and that's fine. If you definitely know these, then that's okay. This is just a review, but we're going to be using them. So if you're a little iffy on them, make sure you jot them down. The little mnemonic device that we use to remember each of these ratios is a little phrase. So, ka, to, a. SOHCAHTOA. I started off with this on the warm-up. You probably heard it last year. And SOHCAHTOA is a way to remember which trig function relates to which sides on a right triangle. So the S stands for sine. The O stands for the opposite leg. And the H stands for the hypotenuse. You can see it kind of goes in order. 1, 2, 3. Right? That's 1, 2, 3. So it's the trig function followed by the numerator followed by the denominator. That's how all 3 of these work. Cosine is the adjacent divided by the hypotenuse. Tangent is the opposite side divided by the adjacent side. Now, the reason these ratios exist, like where they came from, because I'm sure you're all quite interested. Let me draw a triangle for you real quick. Ho. I know, I'm getting pretty good at these. So I've got a right triangle here. And I've got some angle on a side. Let's just say that this is 30 degrees. I could measure each of the side lengths. I don't have them memorized right now, but let's just say that this opposite side is 4, and this side up here is, I don't know, 7, something like that. So if I were to take the sine of 30 degrees, I'm going to get some decimal, some 0 point, and I actually don't know what this is off the top of my head. I'm just kind of making it up. 4, 5, 8, 7, blah, blah, blah. Some crazy decimal, all right? And if I took the ratio or the fraction of 4 divided by 7, I would get some other ratio. I picked bad numbers. These aren't the same at all. Let's pretend that I did do this correctly. But essentially that ratio would be like the same exact thing. And so that's why we say, oh, the sine of 30 degrees is equal to the opposite side divided by the hypotenuse. It's the same ratio. It's the same decimal that you're going to get every time. And even if I took this triangle and I made it a lot bigger, is this angle still 30 degrees? Like, did I make that angle wider or anything? No, I just made the whole triangle bigger. So this is still a 30-degree angle, but these sides are much, much larger. So maybe this is like 10 and this is, I don't know, 22, something like that. But since it's still a 30-degree angle, the ratio of those two side lengths will still be the same, no matter how big or how small. That's what I mean by being in proportion or being a ratio. It's kind of like how 4/8, isn't that the same as 3/6? And that's the same as 1/2. Aren't all three of those fractions equal to each other? And so since they are, that's the same idea as if I had different side lengths. If this was 4 and this side was 8, or if this side was 3 and this side was 6, or if this side was 1 and this side was 2, all those I'd get the same exact ratio of 0.5. It'd be the exact same decimal. And so because of that, we've got these ratios, these trig functions that we can use. And whichever two sides we use will be a different ratio, but that ratio is consistent for that angle. So we can use them, this idea of this ratio or the sine or cosine or tangent of an angle equaling this decimal, that's the same as the ratio of those two of the sides. So for this first triangle here, note it is a right triangle. This little curve here is just saying that, hey, the 25 degrees is pertaining to that corner or that vertex or that angle right there is 25 degrees. And so because these ratios are the same, I can use it to set up a mini equation and solve it for an unknown side length. Now, the one thing that you need to decide on is which trig function should you use, sine, cosine, or tangent. And that's going to depend on the side length that you're looking for, which in this first example is x, and the side length that you're given. So since I don't know what this side is, but I do have this side, I'm looking at that x and that 10, and I need to label them. I need to decide, okay, is that the adjacent side, the opposite side, or the hypotenuse? So how do you determine that? Well, it all comes down to the angle that we're given, not the right angle. You're always going to have a right angle. That's never the one that we use. We never use the 90-degree angle because they all have a 90-degree angle. We're looking at one of those two non-right angles. In this case, this 25-degree angle. And I need to label these two legs, the 10 and the x. Now, one of them is opposite, one of them is adjacent. The easier of those two terms that you're more familiar with is probably opposite. If I'm standing right here, okay, that's me, obviously. Which of those two sides, the x or the 10, which of those two sides is on the opposite side of the triangle from where I'm standing? So if that's me at this 25-degree angle, all the way on the opposite side of the triangle is the x. The 10 is not on the opposite side. The 10's actually right next to me. A fancy math word for right next to is the word adjacent. Things that are adjacent are right next to each other. So the 10 is A, the adjacent leg, and then the x is the opposite leg. So I've got an opposite and I've got an adjacent. So now think back to SOHCAHTOA. Which of those three trig functions, sine, cosine, or tangent, gives me the ratio of the adjacent leg and the opposite leg? SOHCAHTOA. TOA, tangent. So we know that the tangent of that angle, hey, what angle do I use here in parentheses? Our angle that we were standing at, right? That 25. So you'd say the tangent of 25 degrees equals, and it's TOA, OA. So it's the opposite side, which was x, divided by the adjacent side, which was 10. So using this trig ratio, knowing that all 25-degree angles are going to have an opposite and adjacent sides in the same ratio, in the same proportion, I can make this mini equation. Now, if we wanted to solve this equation down here for x, what do we have to do to both sides to get that x all by itself on the right? So right now, that x is being divided by 10. If I wanted to cancel that out, I would multiply by 10, right? Because those are opposite operations. That cancel those both out. But if I multiply the right side by 10, I've got to multiply the left side by 10. So x is equal to 10 times the tangent of 25 degrees. Let's grab out those fancy calculators now, everybody. Now, one thing with angles that we're going to learn later on this year is that there's more than one unit of measurement. You know how if I'm measuring distance, I could measure like the distance from here to my house. I can measure it in feet or in miles or kilometers or inches. Aren't there a bunch of different units for measuring length of something? Well, it turns out angles can also be measured in different units. We've always been using degrees our entire life. As far as we know, that's the only unit of angle measurement. But there's a second one that's a lot better for math called a radian. And we're going to learn about that later on this year. But for now, the only reason I bring that up is because in your calculator, if you go to mode, you can choose between radian or degree. By default, your calculator is in radian mode, which is not what we're doing right now. Because if you see that little circle there, that indicates degrees, right? This is a 25-degree angle. So I need to make sure that my calculator is in degree mode. So you just want to go down here, put your arrow over to degree, hit enter, and now your calculator's in degree mode. Let's go back to the main calculating screen. So second quit back here. And my equation was just 10 times the tangent of 25 degrees. So I just type 10 times tan, and you see whenever you hit tangent, it gives you an opening parenthesis. It's like, hey, I need an angle in here. And you just type 25. You don't need to put the degree symbol because the calculator already knows that it's in degree mode. Hit enter. And did anybody else get 4.66? Fantastic. All right, so you get about 4.66, and that was the side length of x. So if you haven't already, I'd like you to try to figure out these other two side lengths, y and z, on your own. Yeah, I'm not going to be too picky again about rounding, just like in earlier tests. I trust you know how to round appropriately. I'm not It's not really what I'm testing on, but you want to keep it a few decimals just to make sure you get that correct number. And if you're having trouble getting in the right mode based on your calculator, let me know.
You do 10 and then open parentheses 10.
So for this calculator, we're multiplying 10 times whatever the tangent of 25 is. So we want to do tangent of 25 first. And based on your calculator, so this one, I think you type 25 first and then tan. So that is the tangent of 25 degrees. Then press times 10, and there's that 4.66 that I got as well. All right. You're welcome. Anyone else? Calculator question? No, see how yours actually puts the word tan and then a parenthesis? So yours hit tangent first and then 25. Yeah. Try doing 10 first. There you go. I think yours would have worked if you did tan 25 and then times 10. Maybe like hitting the multiplication sign. Worked. Good with these?
Yeah.
Okay, over here. Good with the calculator? Did you figure out how to do the tangent on here? Okay. So 25, then press tangent. And now multiply it by that 10. Oh, clear it out first. So do 25 tan times 10. There it is, 4.66. Everyone here good? You figure out on here? Yeah, you're doing fine. You got it on yours? Cool. Did you figure out how to enter them on here? Nice. Figure out how to use it on this? So you hit 10, and then if you hit 25, so that's the decimal. Now just times 10 for that 10 that's in front of it. So just hit times 10. 4.66. That's our answer. Anybody else? Calculator questions? At home, everyone good with their calculator? Can you do tangent of 25 degrees okay? All right. Just give me a shout out if you can't figure something out, and I'll troubleshoot from here as best I can. All right, see if you can get those other two, solve for y and solve for z if you haven't yet. For this middle triangle, anyone else use sine? Is that the right trig function? Opposite and hypotenuse, that's sine, right? But when I set up the ratio, the y is on the bottom. So in that previous one, a tangent, I multiplied by 10. But this one in the middle, do I multiply by 7 to cancel out that 7? That wouldn't work, would it? Because that'd be like 7 times 7. Well, that doesn't cancel out. That equals 49. And I still have the y on the bottom. Does anybody have an idea of what we can do to solve for y? Yeah, we saw this a little bit in the last unit with these rational functions. Whenever you have a variable in the denominator, we got to get it out of there. You know, I don't want to be dividing by the variable. I want the variable up top in the numerator position. So for this fraction, since the y is in the denominator, I need to get it out of there, so I'm going to multiply by y. Because I'm multiplying by y and dividing by y, those would cancel out. But if I multiply one side by y, I also would need to multiply the other side by y. So those cancel out. I now have y times the sine of 40 degrees equals 7. Now my object is to get the variable by itself on one side. And on the left, the y is being multiplied by the sine of 40. So how can I get rid of the sine of 40 now? What's the opposite of multiplying? We divide by the sine of 40 degrees. So those cancel and leave us with just y. But I'd also have to divide this side. And so then, for our calculation, y equals 7 divided by the sine of 40 degrees. And also as a little shortcut, you may have noticed, looking back at the original ratio here, whenever your variable's in the bottom, to solve for it, all you're really doing is kind of swapping the variable with the trig function. You move the variable to the left, move the trig function to the denominator. Just want to cut out those like 2 or 3 steps that I did to get the y by itself. And so just like we did with the previous one, we type 7 divided by sine 40. It's already in degree mode. Anyone else get 10.89? Wonderful, wonderful. $10.89. And the last one, that 20 degrees up there in the corner, 4 is the hypotenuse because it's across from the right angle. Z is right next to my 20, so that's going to be the adjacent side because it's right next to my angle. A and H, that's cos, C-A-H, that's cosine. So I'm going to say the cosine of the angle equals C-A-H. So that's adjacent Z over hypotenuse 4. I love it when the variable's in the numerator because all you do is multiply by that denominator, right? I just take that 4 to the other side times 4 times 4. And so Z is just 4 times the cosine of 20. So 4 times the cosine of 20 gives us 3.76. Anybody? 3.76. All right, 3.76. All right, that's how you use the 3 trig functions to find unknown side lengths. Give me a thumbs up if you remember this from last year. Okay. Excellent. Any questions on any of these, on how I solved for X, Y, or Z? All right, one more aspect of these is that we can use them not only to find the side lengths, but we can also use them to find the angle. Because if I have the 2 sides that make up the ratio, you know, like that opposite and the hypotenuse, well, then I know that that ratio's got to be set for one specific angle inside the triangle. And so when you're solving for a side length, we use just the basic sine, cosine, and tangent like we just did. However, just make a note somewhere. If you're solving for an unknown angle, okay, so this is the key thing. When you don't know the angle, we use the inverse trig function. Hey, have we ever seen this symbol before and heard the word inverse this year? Yeah. Yes, we had the inverse matrices start things off. We had inverse functions. Remember f of x and f inverse of x? We had a whole unit on inverse functions. Same idea. These are the inverse functions. It's doing the opposite. And so we use the inverse functions. On your calculator, to use them, you just have to press the second button first, or the shift button. If you notice above sine, cosine, and tangent on your calculator, do you see a little like sine inverse, cosine inverse, tan inverse right above them? So inverse trig functions are for unknown angle measures. So we can use these to calculate the unknown angles. So let me show you how we'd set this up. Our unknown angle in this first triangle is x. It's in that top corner there. I still need to identify the sides that I'm given, adjacent, opposite, or hypotenuse, because that tells me which trig function I should use, sine, cosine, or tangent. For this first one, for x, everybody, what are we using? Sine, cosine, or tangent? How do we know cosine? Good. So the 10 is adjacent to the x because it's right next to angle x, the angle that we're looking for. The 20 is the hypotenuse because it's across from the right angle. It's the longest side on the triangle. So we're going to use cosine. Now the way we set this up is we would write the cosine of x. Now that's our unknown, right? That's what we're solving for x. Let me move this over a little bit. The cosine of x equals, and just go back to SOHCAHTOA, CAH, C-A-H. So A is 10, H is 20. So that's our setup using that trig function. The cosine of angle x is 10 over 20. Now I want to get the x all by itself, but it's currently trapped inside of this cosine. How do I get rid of that cosine? Well, I can't like divide by it because it's not being multiplied. Well, it turns out that the way you cancel out a trig function is you just use the inverse of that trig function. So in essence, what I'm doing is taking the cosine inverse of this whole thing, and then what happens is the cosine inverse and the cosine cancel out and leaves us with just x. They're opposite operations. Remember how we talked about inverse functions earlier this year, like f of g of x or g of f of x? When you take the composition of an inverse function, it cancels out and leaves you with just x by itself. That's exactly what we're doing here. But if I take the inverse on the left side, I've got to take the cosine inverse on the right side of the 10 over 20. And that's going to be our actual calculation now. So on your calculators, I want all of you to type in the cosine inverse of 10 divided by 20. So pull this up. Again, look at your trig functions, and just up above them, you should see like sine inverse, cosine inverse, tan inverse. So I press second cosine, and it gives me that cosine inverse. Make sure you see that -1 on your calculator. That'll tell you that you're using the right function. And then it's 10 divided by 20. Anybody else gets 60 degrees. Fantastic. And I know this is degrees, even though there's no symbol, because that's the mode that my calculator's in right now. It's in degree mode. So any angle that it gives me, I know is going to be a degree. So we know that angle x is 60 degrees. All right, see if you can all find y and z. So you have to type the ratio first. So type 10 divided by 20, enter, or equals. Now press second cosine. There it is, 60 degrees. Yep, cosine inverse or trig inverse functions can be a little tricky based on your calculator. You figured it out? Awesome. So for you, it's the shift key.
Okay.
With, see how it's got like yellow writing?
Yeah.
That'll get the yellow writing above every button on your calculator.
Okay.
So since cosine inverse is right up above it, press shift and then cosine.
Okay.
Yep, and see how you've got that inverse symbol there? Now just
Yeah.
type in that ratio, 10 divided by 20, 60 degrees.
Okay.
You got it. You're welcome. You figured it out in here?
Yeah, I heard it.
Good, good. You got it? So you aren't in degree mode, right? So hit the mode button right there and go down where it says radian, and you just switch it over to degrees. Hit enter. All right, so now if you were to type in that same exact calculation, it gives you it in degrees instead of radians. Good. You got it on here? All right. Tangent 7/6. Yeah. Yeah, good work. Figured it out? Yeah. Nice. You got it on there? Everyone over here, figure out how to use the inverse functions? Yeah, try not to choke. Did you get it? Yeah. You got it on yours?
Yep.
Yeah, nice. Looks good. Looks like everyone's pretty much got it. This middle one, we'd say the tangent of angle y is the opposite over the adjacent. TOA, 7/6. So to find the angle y, I'm going to simply take the tangent inverse of 7/6. So in our fancy calculator, we press second. Yep. So this is 49.4 degrees. And last for z, this is the opposite side. That's the hypotenuse. I'm going to use sine. So sine of angle z is opposite over hypotenuse, 4/12. So to solve for z, I'm going to have to take the sine inverse of 4 divided by 12. So sine inverse of 4 divided by 12. 19.5, anyone? Yeah? 19.5. Z equals 19.5 degrees. Okay, what do you think? Can you handle this? Crazy advanced mathematical skill? No, it's pretty basic. Hopefully feeling confident. Any questions on these inverse functions? Luckily, the setup's still the same, right? The ratio of the sides, you're still doing that same SOHCAHTOA business. Okay, one last thing that you'll see occasionally is when a question says solve the triangle. To solve the triangle, it means you need to find all 3 side lengths and all 3 angle measures. Whoa, it's a lot of work, right? So like looking at this first one, I have 2 sides already, 8 and 10. How can I find this last side length? What would you use? We could use Pythagorean theorem, right? So then you have that, but how do you find these angles then? How do you find an unknown angle? What do we have to use? Yeah, here's a big hint. That whole last slide found unknown angle measures. And you can use any combination of ratios as you want. If you have all three sides, you can use sine, cosine, or tangent, because you'll have the opposite, the adjacent, and the hypotenuse. Then over here, this one, how many angles do I actually have for the triangle on the right? I've got the 55, but do I know how many degrees this is? We do. How on earth can I figure out that third angle? Here's another skill. What do all three angles on every triangle always add up to? 180. So I could just start from 180 degrees and subtract the 90 and then subtract the 55. And that'll be the easiest way to get that unknown angle. And one last thing that you might see on problems for an unknown angle, typically instead of using our like English letters, X, Y, Z or whatever, mathematicians and scientists love to use Greek letters. And so the most common one is this one called theta. So if you ever see a weird symbol like that by an angle, treat it just like you would any variable, like X or Y. You're just going to solve for that angle. All right, so all I wanted to show you with this slide is what solve the triangle means. But that's it for today's lesson. Dun, 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 dun. Wow, we have a lot of time left. Nope, even better.